the story. And if you look, hang on, if I can. I don't know if I can copy and paste this. See, I mean, if you have a heart attack, that's what they're looking for. Let's see. Okay. This is in the answers. I don't know if I can get it to cut and paste, but this is in the answers of the review question, the review quiz 6. If you haven't looked at that, then do. I don't know if that's going to copy and paste, but we'll see. Okay. I can make that wider. Okay. This is what you need to remember. If the concentration of H+, the proton, remember, because hydrogen is only an electron and a proton. So if you lose the electron, all you're left with is the proton, still called H+. If the concentration of H+ in the blood increases, you've got too many of them, then that's called acidosis, low pH. What do we need to fix the situation? If we add the H+ and the bicarbonate ion all together, let's move that over, and reform the carbonic acid. So we want to add that, reform the carbonic acid. That's going to use up all the excess protons. So it's removing H+ from the whole equation. All right. If the concentration of the H+ in the blood decreases, too few protons, we've got no protons. So now what have we got? What have we got? We've got too few protons. The blood is not acidic enough. What's it called? Alkalosis. That's right, alkalosis. That's high pH. How can we fix that? That's right. So we can.
Please, what disassociate?
Okay. If the carbonic acid dissociates to provide more H+ and more bicarbonate ion, so this reaction produces more H+. I can cut that out. I don't need that. So we're adding H+ to the situation. If we dissociate, if that dissociates to provide H+, I'll write here and, that's confusing, and HCO3, the bicarbonate ion. So we're adding H+ to the blood, okay? And pH will fall, yeah? So if the concentration, if the pH of the blood is too low, we need the carbonic acid to dissociate, provide more protons and more bicarbonate. This is why hospitals use up all the bicarbonate and you can't get any for your baking at Christmas. Literally, just before Christmas, the hospitals buy bicarbonate in bulk because of all the people who are going to go and play cricket on the beach and have heart attacks because they've done nothing all year. You'll notice that if you go around looking at the supermarket shelves before Christmas, you'll see that there's no bicarbonate.
So what does the bicarbonate do then?
Bicarbonate,
Is a heart attack then a question of acidosis or alkalosis? Because people get heartburn before they have a heart attack, isn't it?
yeah, so usually a heart attack is acidosis.
Okay.
And so that's why they're looking for the bicarbonate, because they're adding the bicarbonate to the blood so that it will mop up all of the extra H plus, reforming carbonic acid.
Oh, and the body can't make that naturally.
Yeah, but not if you've been dumb enough to do something, dumb. Your body does make it naturally, and that's what's buffering. But if you go and do something dumb, for instance, if you were to take an overdose of aspirin and cause a huge increase in the H plus in your blood, you would have to be given a whole ton of bicarbonate to mop it up. Your body wouldn't make enough quickly enough to mop it up to prevent it from killing you. And so it's the same thing with heart attack. Heart attack, the damage caused from a heart attack produces far too much protons for your bicarbonate that you make naturally. So if you hyperventilate, what you're doing is you're removing carbon dioxide from your blood. So that reduces the amount of carbonic acid, and that's why you breathe in a paper bag to replace the carbon dioxide into your blood. I mean, your brain reacts quite quickly to your blood pH being wrong. You die quite quickly from it too. So it's an emergency situation.
So just for interest sake, so the blood pH buffering is hyperventilating, it is the stomach acid, is it all the acid then? Lactic acid, DNA, RNA, all of it. Is that all to do with the buffering system?
We're only talking specifically about blood buffering.
Oh, blood. Oh, yeah. Okay.
So we're only specifically talking about blood. Yeah, DNA is a bit different because it's so well protected inside the nucleus. You wouldn't want that damaged or messed with in any way. So that's carefully wrapped up to stop you from being able to do very much with that. But your blood is quite. I mean, you've got the toxins and all of that rushing around your blood, and you're hoping that your kidneys will be clearing that. But if your kidneys are not clearing it, then that's why it's a serious problem. That's why you have to have dialysis, because you've got to get all the toxins out of your blood, because your blood has to stay within that very narrow band of pH. And so if your kidneys and your blood buffering system, your bicarbonate system is not up to the job, then that's why you would need help.
Wow. So in the blood, it's basically your positive or negative feedback system and buffering.
Yeah.
Right.
Yeah.
Okay. Yeah. Interesting, because that means everything has got to do with chemistry. Hey.
Yeah.
You have foundations, like then you can't carry on.
That's right. But I've got a sad thing to tell you, and it's sad to me, but it's true. Chemistry has everything to do with physics. I failed physics, of course. No, in fact, I even dropped physics. But yeah, it has everything to do. Actually, that reminds me. I told a lie the other day. I said the only test I'd failed was, apart from my driving test, was one that was an open book exam. But actually, that's not true. I remember I failed maths and chemistry at O-level. The worst grade you can get. Anyway, like I say, do look at the video that I made. because it is really important. It turns up in this exam, it turns up in the biochemistry exam, it will definitely turn up in nursing for sure. And you never know.
So what
You might save someone's
part
life.
of it's in the exam?
What part of it?
Like, what do you? Yeah.
The question will
Like, what do you need to know?
the question will pretty much be very similar to, hang on, the question on page. The question in the exercise is on page 65. And the answers are online. I've put the answers to you, and they're not hidden from you or anything like that. But that question will come up. It will come up in one direction in the chemistry test, and it will come up in the opposite direction in the biochemistry test. And I can't remember which way round it goes. But you need to see this equation sign. You can see this little arrow pointing in both directions.
So by it like being the other way around, what does that mean? Does that mean that it'll just the two bicarbonate and whatever that one's called swap?
Hang
like
on,
this?
if I did that. If I did that, it's still the same thing, yeah? Exactly the same thing.
Right.
It's the other way around. Doesn't matter which way round you see this. I want you to be able to recognise it and know what it's saying, whichever way round you see it.
Yep.
Yeah, because this is telling you that it's going back and forth, back and forth, back and forth continuously. Continuously, this is going
Okay.
on. That's
So
what buffer is, really.
Can you have like one without the other? Because once it does, let's go over hydrogen, then it becomes the other one and stuff. So can you just have like bicarbonate in water by itself, like, or will it turn into?
I see what you're saying. If you put the bicarbonate into water, now when you buy it in the shop, it's sodium bicarbonate that you buy. And when you drop, and what do you know about sodium bicarbonate?
It's got sodium and bicarbonate.
Yeah, yeah. But what's the bond? How's the electron sharing going on? Because this is what we come down to every time: is how's the electron sharing going? So if we've got sodium bicarbonate, let's get rid of this. Well, can I put a new one in? If we've got sodium bicarbonate, Na. If I've got sodium bicarbonate, what kind of bond sharing is there? Actually, I can make you some sodium bicarbonate. Sodium. No.
Would it
be a covalent? Because
hang on, let me see if I can find some sodium. Everything, oh, look, here's one I happen to have. The wind has blown into my Tifaria party. Okay. Now I've got sodium bicarbonate. Yeah? So what kind of bond is this between the sodium and the bicarbonate ion? It's between a metal and a non-metal.
So does that mean if it's between a metal and non-metal, is it always ionic?
Pretty much. For our purposes, we'll say yes. There can be circumstances, but we'll say yes. Okay, so when we drop our sodium bicarbonate into water, we've got bicarbonate, haven't we? And we've got sodium.
Right.
We know that we're going to lose that. We've got bicarbonate. That's what we have, and that's going to be soluble, yeah?
Mm-hmm.
Yeah?
Yep.
So in answer to your question, yes, we could just have this.